Finding the area of a triangle or parallelogram in the coordinate plane. So I know this one looks a little bit more difficult than just finding the regular area when you're given all the pieces, but it's not too terrible. We do need to remember to find area of, and I'm going to put a little triangle here. We want 1/2 base times height. So when you're looking at a triangle, and I'm going to just draw a general triangle here, the height is the line going straight down, and it's usually shown with a dotted line, and it has a little right angle mark on it. So this is the H. The base is the line that connects, so it goes from a vertice down to a line. This is the base, or the B, okay? So this line here. So it doesn't matter if it's drawn this way or if you take it and you turn it sideways like it is in this picture here. You're always looking to go from a vertice straight down to the other side. And we want to try to do that the easiest way possible to get a height and a base. And if you have the area of a parallelogram, I'm going to try to draw a parallelogram there, you just have base times height. I'm going to draw this one kind of over here. So if I have a parallelogram, like this. So the height is most likely going to be drawn like this, with an H. Sometimes it's drawn out here outside, and they'll put a dotted line to it like this. That's also a height. Either one should be exactly the same height, because that's how parallelogram works. Opposite sides are congruent. So I can go from this height to this height, and it will still be the same distance, or the same length. The base, remember, height has to be at a 90-degree angle here. That's why they end up drawing that dotted line out so you can see the little 90-degree mark. The base is what this line is going from. So it's always going from a vertice down to another line. That is the base. Sometimes in parallelograms, though, they will actually give you the length for the base that's on the top. Well, again, parallelogram, opposite sides are congruent. So if they tell you what the top is, you know what the bottom is. If they tell you what the bottom is, you know what the top is. Same thing for left and right. So you can always go across opposites on a parallelogram, okay? So when we get there, we will definitely figure that one out. But in this case, when they give us these ones, and it looks like they're going to give them to us a little bit nicer for this one, just to learn how to do it. So I can really easily go from this point straight over. And they actually show you that, I believe, right down here. So they show you that here. So you can go from 7, 3, and you can go straight over to this line and just count. How many do I go over? Now they're not showing me the grid, but I know I'm going from an x-coordinate of 7 to an x-coordinate of 3, because that's what both of these are 3s. So if I'm going from 7 to 3, well, I moved 4 spaces over. Sometimes it's nice when they give us the grid. It doesn't look like they're going to give us the grid to actually count on this one, because there was no grid on that first one there. So I know the height is 4. And then when I look at the base, because remember that goes from the vertice to the right angle here, the base is the one that's the right angle is connected to. So here's my base. So I'm going from 6, because this went all the way up to 6, and I'm going down to -5. So I know I have 6 here, going from the x-axis up, and then I have another 5 going below. So that's a length of 11. And the reason it becomes 11 is because you have 6 minus -5, and it becomes plus. Or more accurate, you go 6 plus the absolute value. So you'd have the absolute value of both. Because I don't want positive and negative. I just want 6 and I want 5, because I want to see both sides of this, okay? So we just want to see how long it is. And we can count it, and we can just go, oh, we're going from 6. Here's 6. We have 5 more on the bottom. So 5. We just have to be careful about that positive and negative. And then we just plug it into whichever equation we're going to be using. So in this case, it's a triangle. So we have 1/2. Our base was 11. And our height is 4. So we multiply, and we get 22 square units. All right, so let's go ahead and try this out. And I'm going to switch up my color here. Okay, so I'm going to go to blue. All right, so they give us a parallelogram to start with here. So what we want to do is count for a height here. Let's see. So we have -5 and -5 for our x. So this is a straight line going up and down. It played a little bit of trick on my eyes there. I thought it was a little crooked, but it's actually a straight line. I can see that because for this point, I had to come over to -5 and up to 6. And then for this point, I also had to come over to -5, but I went down to -3. So I know I went over the same distance for both. So this is a straight line. So we want this to be our base. That's going to be the easiest thing. Now we want to find our height. So I'm actually going to draw over here so you can see what I'm talking about to do, and I'll get rid of this in a minute. Like that. So ignore this little line here. Sorry, I went too far. All right. So what we want to do for our height is we actually want to go like this. And so that should have been a dotted line. So we just want to figure out how far is this distance if I go from this point over to the point above where it ends. So on this one, we're moving on the x-axis. So we want to look at the x's. So from this point, it was -5. Remember, it's -5, 6. But I'm just looking at the x-coordinate, so it's -5. And when I move over here, the x-coordinate over here, so the whole coordinate is like this. But remember, I'm only looking, I'm sorry, that's the coordinate down here, but it's still the same thing up here. So the x-coordinate is 4. So remember, when you're dealing with positives and negatives, and I'm going to try to draw this a little accurately. So here's my crisscross my axes. I have 5 on this side. I have 4 on this side. So I moved 5 over, and then I moved another 4. So my height is 9, because this distance is 9 here. And then we also want to look at this one here. So we have -6 and -3. Remember, the 5s are the same. We talked about that already. We had to come over to -5 for both. So in this case, I have -6. Oops, not -6. 6 and -3. Sorry, I wrote that wrong. So remember when I got rid of my little crosshairs here, but this is close. I have to come down 6, and then I have to go another 3. So that means this one is also 9. Okay, so now I have a base and I have a height. For parallelogram, all I do is area equals base times height. So 9 times 9, I get 81. And I click check. And I got it right. All right, next one. So this one's a little bit manipulating, and I'm kind of over explaining how to count on there. I don't have a full grid over here, but I'm trying to make sure you understand how to count the base and the height. So with this one, I'm going to draw this triangle here, and then we have this x-axis going right through here. So the y-axis is off to the side over here. It's not even really going through the triangle at all. We have -6, 1, -1, 1, -3, -5. All right, so here's my basic drawing. And what I want to do is I want to find the flat side, because that's going to be the easiest thing to have as my base. So I either want it to be flat going left and right, or I want it to be going straight up and down, because it's super easy to count those ones. Because from here, I'm going from -6 to, and this is a comma, -6, 1, and I'm going to come over here to -1, 1. So they both have a 1, which means that for my y coordinate, I had to come up to 1 for both of them. That tells me it's a flat line. So I'm going to focus on the -6, and the -1. So I don't have to come over to the axes and then keep going. So I just want to figure out how far do I need to go to get from -6 to -1. And the answer is 5. I'm not going to put -5. I have to go over 1, 2, 3, 4, 5 to land on that one. And I know, again, there's not a grid. So you may want to put this on grid paper and actually graph it if that makes it easier for you to count. My height is going to go from that base to this vertex here. So the kind of opposite angle. And that's at a 90-degree angle. So it just comes straight down here. And I just want to count what's the distance. So I'm going to look, because I'm working on a vertical line, I know that my y is going to change, because both would come over to -3 if I went over -3 down -5. Well, I would go over -3, and then I would go up to 1, because that's where this line is landing on, is 1. So I have to go up 5, because it's -5, so I have to move up 5. Then I also have to move up another 1. So that makes this whole dotted line a length of 6. So now I know it's a triangle. I'm going to come to this area of a triangle equals 1/2 base, which is 5, times height, which is 6. So I have area of a triangle equals 1/2 base times height, which is 30. And remember, if you go to a calculator, so they're not allowing a calculator on this one for whatever reason, but most calculators don't just have a fraction bar on them. Like this one, there's no fraction on this one. So 1/2 times 30 is the same thing as 30 divided by 2. Means the same thing. So we get 15. So we know that the area of the triangle equals 15, and then it would be square units, but they already wrote that out for us. So just make sure, if they had told us what the length was, like that each unit was a foot, then we put 15 feet squared. But in this case, they're just talking about square units. So we write 15 and check. All right, so let's see. I wrote this awfully close. I need to write it a little lower next time so I can just erase it, but let's see. Can I undo all of it? Nope, darn it. It only lets me undo so many times. There was too many dashes in there, so let's see. I'm going to have to rewrite my equation there. Great. All right, so we have parallelogram equals base times height. And my little arrow going over here. Okay, so for this one, we want to click next first. All right, so this is our last one. We have a parallelogram. So here is my very nice parallelogram. And we have -4, 6, 3, 6. We have 5, 1. It's a 5. And we have -2, 1. All right, and then this goes through right about there. The x-axis is actually, I'm going to put it right below here just so it doesn't go through my coordinates here. So it's right below here. All right, so this is kind of close. It'd be much more accurate if I had an actual grid paper to go through and do this on. But again, we want to look for the flat side. So in this case, I can kind of see on that on the picture that this looks pretty flat. And I can confirm that by looking, do either one of the pieces of coordinates match? So 6 and 6 match. What that means is that I had to come up to 6 on both. So for this one, I had to go over to -4 and then up 6. This one, I had to go over to 3, up 6. So I had to go up 6 for both. So that tells me that this is a flat line. Remember, for this one, now for the length, I need to look at how much did I move from this point to this point. So I have to go -4, or I have to move 4 units, and then I have to move another 3 units to get to this one. So together, I have to move 7. So this line is 7. All right, now we need a height. So we want to go from a vertice, and I'm just going to grab this one, and I'm going to go straight down to like a right angle here. So I want to know what the height of this is. So if I know I had to go up to 6 to get to this point here, remember we just talked about that. For this line here, what did we have to go up to? If we look at these coordinates, we had to go over -2, up 1. For this coordinate over here, I had to go over 5, up 1. Oh, we had to go up 1 for both. So I know that I had to go up 1 here too. So I don't want this area. I don't want this 1. I'm scribbling it so you know you don't want that 1. That's kind of empty space. It's not in the parallelogram. So with this one, I went up to 6, and I went up 1 here. So the whole thing is going up 6, but I don't want this 1. So I want to take the 1 away from the 6 and get 5. And again, if you did this on a grid paper, you would very easily be able to count those 5 spaces. All right, let's go ahead and do the math now that we have our base, which is 7, and our height of 5. So we have area equals base times height. So area equals 35. So the calculation itself is pretty dang easy. It's just looking at the coordinate and making sure you understand exactly how to get those 2 lengths. All right, we're all done.